Good day, everyone. Now, in our previous topic, we learned on how to calculate the current of a simple circuit, one source, one load. We are able to provide the theoretical idea on calculating the current using the EMF of the battery, the internal resistance, and also the load resistance. And we also inform or learn that if another load connected on the circuit but in series connection, we found out that calculating the current is almost the same as calculating the simple circuit with one source, one load. We just add the resistance and divide it with the electromotive force or the EMF. Now, what will happen if another resistor connected in the circuit but it is not in series, it is in parallel, or might be a combination of the two? Then in this video we will study on the resistor connected in series, connected in parallel, and connected in complex circuit. We will study on how to provide the solutions of the circuit for series, parallel, and complex. So again, let us recall that if we have one source, one load, we call it a simple circuit, then electrons will travel when you close the circuit. And notice, remember that the electrons travels from negative towards the positive of the circuit. But in a conventional flow, current is flowing from positive to negative, which means that we assume that the proton travels towards the electrons. But remember that it is the electron travels within the circuit, but the opposite direction is current. So there are two basic circuit connections. We have the series connection. The loads are connected in continuous or single path, which means that from the source, which is we call this as the equivalent voltage, it should be connected to one leg of the resistor, and the other leg will be connected to another leg of the second resistor. Then the second leg of the second resistor connected to the one leg of the third. Then the other leg of resistor 3 will be connected towards the negative source. So this is a so-called series connection. Now, in parallel, this is opposite to the series, because the current now will be split, which means parallel connections forming a junction, which means there is a point wherein the current separate to each other. So if we have resistor 1, resistor 2, resistor 3, in parallel connection, this is one way to connect that resistor. So notice that the legs of the three resistors are connected as one. So this one will connect at that point. This one is also that point, but which is the same as this. And also the leg of 3 connected to the leg of 2 and connected to the leg of 1. And their opposite legs was also connected in common. And they are connected all in positive, the negative. The other legs of the resistors, which are in common, connected to the source positive. So we still have the equivalent voltage, which is the source. We have R1, R2, and R3. These are the two basic connections, the series connection and the parallel connection. Our task is to find the formulas. What are the formulas that can calculate the, for example, the total or the equivalent resistance of the three resistors in series? What will be the equivalent resistance? And also with, since we have three resistors, then it follows that there must be a corresponding voltage on each resistor, as Ohm's law says. Whenever there is a current, there is a resistance, there is always a voltage of that circuit. So what is now the relationship of the equivalent voltage towards the individual voltages of R1, R2, and R3? And so with in parallel connection, what are the equivalent voltage and equivalent resistance. Okay? So since there must be a current for every point also, then what is the relationship of the current that passes through the source? We call that as equivalent current in relation to the current passes through R1, R2, and R3 in series and also in parallel. Those are the things that we need to learn today. What are the formulas that can be applied in order to solve theoretically on these circuits? Now, the idea of having the solution of series and parallel is very much important in the field of calculations of the circuits because we can always apply that anytime. Now, if the circuit is connected in two connections, series and parallel, we call it as complex, that formula can still be applied to that circuit. So which means that we need to understand how to solve the circuit in series, circuit in parallel. Okay, so let us have now the formulas. What are the formulas in simple series? Now take note, as I've said, that if we have the resistor, then there must be a corresponding current, which means that in R1 we have I1, in R2 we have I2, in R3 we have I3, corresponds to the current that passes through its resistor. And also there must be a current that passes through the source. We call that as equivalent current, I equivalent. The V equivalent is the source voltage. Now, in series, this is very important, in series, current must be constant. The reason is, there is no split of electrons that passes through the conductor. The analogy is, you can think of water that passes through a pipe. So if there's no junction of the pipe, then the amount of water that in must be the amount of water must come out to another end. So since there's no split, current must be the same. So in other words, that the equivalent current should be equal to the individual currents of each resistor connected in series. Meaning, I equivalent is equal to I1, equal to I2, and equal to I3. The good thing is, if you know one of this current, for example, you know how it is I3, then all the currents in circuit must be the same. So there's no changes within the current, assuming conservation of charges. Okay, then what else? What is the relationship of the resistor or the individual voltages towards the source voltage? We call it as V equivalent. What is that equal to? Now remember again, at any point of the circuit, there must be a voltage. So in R1, there must be V1 and I1. Respectively, we have also V2 at R2 and V3 for R3. Then, of course, we have the V equivalent, the source, because all points in the circuit must have the voltage. So, the question now is, what is the relationship between the equivalent voltage towards V1, V2, and V3? The answer is, just add everything, V1, V2, V3. And the question is, why? Now, take note, in our experiment in voltage of a simple cell, we connected the 3 batteries to 2 batteries. As you increase the battery connected in series, the voltage also increases. And the data results that if we have one battery which is 1.5 volts added by another battery, the result is 3 volts. If we add another battery connected in series, the voltage is almost equivalent to 4.5. And we can notice that as you increase the number of batteries in series, the voltage increases, summing up all voltages on each battery. So theoretically, that is one of the basis of this formula, that in series voltage must be accumulating, which means that the V equivalent is V1 plus V2 plus V3. Now, what else? What is the relationship of R1, R2, R3 towards the R equivalent? How to calculate the equivalent resistance within the series? Now, the answer is just add everything, R1, R2, and R3. Now, this formula can be verified using formula number 1 and number 2. Take note that in formula number 2, V equivalent is V1 plus V2 plus V3. Now, if we use the Ohm's law to calculate V1, remember V1 is I1 times R1, so you can replace that here. And also V2 respectively is I2 R2, V3 is I3 R3. Then take note that I is common, and also the V equivalent is I equivalent times R equivalent. Then the I should be the same in equation 1, so which means that we can remove all the current by dividing one of the current. And the result is R equivalent is equal to R1 plus R2 plus R3. Okay? So that's it. These are the important formulas, which means that if you are given the circuit in series, you are free to use on these formulas. And remember, these formulas are applicable only if that is connected in series. Okay? So, next question is, what are the formulas in parallel circuit? Now, the same as in series connection, we still need to have what is the relationship of the voltage towards individual voltages. What is the relationship of I equivalent towards individual current that passes through the individual points in the circuit, and also the equivalent resistance. So we need to know the relationship of the three components, the voltage, the current, and the resistance. So first, what do you think? If in series, current is constant, meaning there's no difference of the current that passes through each in the circuit because they are connected in series, just like water travels on the pipe. How about the parallel connection? Are they the same, constant? Of course not. Why? Because take note, if we use the analogy of water, which coming from the positive source of the equivalent, then at this point in the parallel, there must be a split, which means there is a junction. And the current must be divided by parts, which means that the one part of the split is not obviously equal to, of course, not equal to the source current. Why? Because it was split by 2, which means that there must be another current. So meaning current is not constant in parallel. Now, if the current in parallel are not constant, the voltage must be constant. Meaning V1, V2, and V3. If you add V1, V2, and V3, the voltage that passes on V1, V2, and V3 are the same. Which means that if the source voltage is 12 volts, V1 is 12 volts, V2 is 12 volts, V3 is 12 volts. Because in parallel, take note of this, voltage is constant. Well, if the series current is constant, in parallel, voltages are the same. Now, why? What do you think? What are the proof, evidences, one of the evidence that shows voltage in parallel are constant? Now again, you have to recall in our previous experiment, the voltage of a simple cell. We measure the voltage of the batteries in parallel, and we found out that even if you increase more and more batteries in parallel, the voltage reading in the voltmeter does not change, which means that the voltage are constant, which means that V equivalent must be equal to V1, V2, and V3. So, what about the current? Since the current is not equal, so what is the relationship of current towards I1, I2, and I3? Okay? Now, remember, as the current flows towards the junction, there must be two currents in a split. We have this I1 that passes through R1, and we have the current that passes through R2, and similarly, we have the current that passes through I3. Now, take note that this current will travel in the circuit, and at the common point, this I1, I2, I3 must be added. And this the sum of I1, I2, I3 must move towards the source. And this is the result is the equivalent current. Meaning the equivalent current is equal to I1 plus I2 plus I3. Just like, again, the analogy is water. If you have 5 glasses from the source, then it will split at this point, then split again, then at this point, the 3 must be combined for network purposes. Because the circulations of electrons, okay, will continue. So meaning, at this point, I1 must be added to I2, must be added to I3, and that is equal to I equivalent. So you can see the difference between the simple series and simple parallel. That in parallel, take note, in series, current is constant. The voltage accumulates, meaning B1 plus B2 plus B3 equal to the equivalent voltage. While in parallel, the constant is voltage, while the current accumulates, meaning the individual current within the circuits, you must take the sum, and the result is the I equivalent. Now, what about the equivalent resistance to its individual resistances R1, R2, and R3? Now remember, again, we have this R equivalent at the point in the source. If we have B equivalent, I equivalent, there must be R equivalent, because according to Ohm's law, the 3 factors must present to any point of that. And remember that Ohm's law is applicable only, the formula for Ohm's law, applicable only for point in the circuit, which means use the B1 at that point and use the current at that point, and the resistance must be at that point also. You cannot jump R1 to R2, B1 to B2, okay, using the Ohm's law. You have to use the Ohm's law at that instant, at point in the circuit. Okay, so if you do the same in because the total resistance or the equivalent resistance is the sum of is the result of combining equation 1 and equation 2. If you do the same in the parallel side, since our V equivalent, our I equivalent is I1 plus I2 plus I3, while the voltage is constant, you can apply Ohm's law in equation 2. Remember, Ohm's law, I is equal to V over R, which means that I equivalent is V equivalent over R equivalent. And also I1 can be calculated using Ohm's law respectively by dividing V1 by R1. So if you divide V1 R1, the result is I1. So you can replace it here. And also this I2 can be calculated by dividing V2 over R2. And also I3 dividing V3 over R3. And remember, voltage are constant, which means we can remove the voltage because they are equal. If you divide one of the voltage in the equation, it leaves us 1. So meaning this will become 1 over R equivalent is equal to 1 over R1 plus 1 over R2 plus 1 over R3. This is the relationship of the equivalent resistance towards the individual resistances. Now compare the two. In series, the resistance accumulates, meaning if you increase more resistors, the resistance will keep on increasing. But in contrast, in series, if you connect parallel, sorry, if you connect another resistors in parallel, the equivalent resistance will keep on decreasing. So this is less resistance, while this one high resistance for the series. Of course, we have the advantages in parallel. We have also advantages in series. In household connection, the connection are in parallel because the source voltage from our source 220 volts from the source of electricity, then we always use the 220 volts. So therefore, the connection should be in parallel because we must get the 220 volts from the source always. So it should be connected in parallel. And the bulbs that we use, the appliances, are all supplied by 220, most of the time, 220 volts in our case. So therefore, household should be in parallel connection. But in Christmas light, for example, it should be in series. Less voltage, okay? We have a minimal voltage of the LEDs, then connect it in. You can connect that in series in order to attain the 220 volts. So again, there must be, depending on your needs, you can use series and you can use in parallel. So if you are to solve the problem in series and parallel, then you have to use the respective formula and you have to memorize this, or you can derive the formulas. Okay, now if we have a special formula here. If we have only 2 resistors, you can take the product of the 2 resistors, the product of the 2 divided by the sum of the 2. This derivation is taken from this one. If you consider in the 2 resistors, remove this 1/3, then apply the algebra, combining 2 fractions, then solve for R equivalent. The R equivalent is the product of R1 and R2 divided by the sum of R1 and R2, which means that the product of the 2 divided by the sum of the 2 is the equivalent resistance of the 2 resistors connected in parallel. So the good thing is you cannot you can escape the reciprocal, because sometimes students are provide an error answer. Why? Because they thought that this one is already R equivalent. This is 1/R equivalent. So after summing up 1/R1 plus 1/R2 plus 1/R3, you have to take the reciprocal of that in order to obtain the R equivalent. Okay? So this is only limited for two resistors. The product of the 2 divided by the sum of the 2. Now, for example, if you have 3, what happens if you have 3 resistors? Then all you need to do is to combine R1 and R2 by product of the 2 divided by the sum of the 2, and the result, do it again, the product of the 2 divided by the sum of the 2. So if there are more resistors connected in parallel, you can chop it by 2, then combine by 2 until the R equivalent can be obtained. Okay? So that's it. Now, let's have an example. Problem 1, series. The question is, calculate the following: the current I1, I2, and I3, and the voltages V1, V2, and V3. And this is the circuits. The source equivalent voltage is 12 volts, R1 is 8 ohms, resistor is 10 ohms, and we have R3, resistor 2, 10 ohms, resistor 3, 6 ohms. These are connected in series, which means that, do not forget the formula, that the current is constant because series, voltage accumulates, and also the resistance accumulates, meaning R1 plus R2 plus R3. So, how will you calculate the current in this? There are many ways to answer that. Now, since given R1, R2, and R3, then the first problem can be solved, or quantity, is the R equivalent. Remember, R equivalent is R1 plus R2 plus R3, which means if I add 8, 10, and 6, the result must be R equivalent. Then after that, we can use the Ohm's law because the result is R equivalent, meaning the equivalent resistance in the circuit, which means in the source. Then we can now calculate the I equivalent at using V equivalent over R equivalent using Ohm's law. And take note that the current is constant, which means after calculating the I equivalent, we can now solve I1, I2, and I3 because current are in constant, in series. And after that, we can individually calculate the voltages because of Ohm's law. So specifically, or at the certain point of R1, at point 1 circuit, R1 multiplied by V1 or by I1, which is the same as the equivalent current, then the result is V1. And so with V2, V3. That's it. This is a very simple problem. Now, in parallel, In parallel circuit, again, we have problem number 2. Calculate the following currents, I1, I2, and I3, and I equivalent, and also the V equivalent. So, and this is the circuit. So, same resistor, R1, R2, R3. We have R1, R2, and R3, but they are connected in different connections. We have series, problem 1, parallel, problem 2. So, how will you work in this problem? So, again, I'll try to use this one, pen tablet. So, the first solution to this problem, number 1, is to solve for R equivalent. Okay, so it should be R1 plus R2 plus R3, and this must be equal to 8 plus 10 plus 6, and the answer is 24 ohms. Okay, so since we have already the R equivalent, then we can solve for what? Because this is R equivalent is equal to 24 ohms, then we can now solve for I equivalent. And I equivalent is equal to V equivalent divided by R equivalent, and this is 12 divided 24, and this is equal to 0.5 amps. Okay, so the I equivalent is 0.5 amps, and take note that current is constant, diba? So therefore, whatever current in equivalent, it is the same as in I1. So therefore, for I2, since they are connected in series, then the current must be the same. And so with I3, and this is 0.5. So therefore, again, these are the solutions of the problem. What is I1, I2, and I3? Now, what is V1, V2, and V3? How will you calculate that? Okay, notice on this that the resistance R1 is given and I1 already calculated. Then V1 can be calculated by what? I1 times R1. But I1 is 0.5, and this is 8 ohms for the resistance. Then the answer is 4 volts. Okay? For V2, again, use this data to calculate V2 using Ohm's law. It should be I2 times R2. But what is I2? I2 is 0.2 and R2 is 10, which means that V1 is 5 volts. Okay. Now, what about V3? Again, our V3, at that junction, V3 is I3 times R3. But I3, again, current is constant, so it should be I also, multiplied by what? R3. R3 is 6. And the answer is 3 volts. So therefore, these are the answers to the problem. V1 is 4 volts, V2 is 5 volts, then V3 is 3 volts. Now, if you want to check for accuracy to this answer, we can verify. We can verify the results. If you add V1 plus V2 plus V3, the sum is 12 volts. Take note that formula for the equivalent voltage in series accumulates V1 plus V2, V3. Our results shows that the consistency of the formula. So therefore, these are the solutions to the problem. Now, what about problem number 2? Problem number 2, because the all resistors are connected in parallel, then remember in parallel, voltage is constant. Okay? In series, current is constant, but in parallel, voltage is constant. Which means that the voltage V1 is equal to V equivalent. Meaning, this is also 12 volts. And V2 is also 12 volts. V3 is also 12 volts. Okay? Why? Because they are connected in parallel. So, this answers to the problem, calculate the voltages. Now, what is I1, I2, and I3? Very easy. Since we have already V1, divide V1 by R1, then the answer is I. And according to the problem, the source is 12, then V1 must be 12 also, divide by 8. Okay? So this is by 4, this is 3 amps, or this is equal to 1.5 amps. Okay? What about I2? I2 is, again, respectively, V2 over R2. You cannot jump voltage V1 or R1 to R2. You have to use at that point because you are using Ohm's law. So this should be, again, 12 volts over 10, and the answer is 1.2 amps. And finally, I3 is what? V3 over R3, and this is 12 over 6, and the answer is 2 amps. Okay, that's it. So this answers to the problem. If you want to verify this, the accuracy of this, you can calculate the I equivalent. So you have to add, you have to combine this one, the 1.5 plus 1.2 plus 2, we call it as the I equivalent. So this is 2.7 plus 2, 4.7 as the current. Okay? So 1.5 plus 1.2, 2.7 plus 2. Okay? Now, you can verify this again. This is the total current, but this is not required. But you can verify the accuracy of this after calculating the R total. What is R total? R total, remember, is the reciprocal. Okay? R equivalent, 1 over R equivalent is over R1 plus 1 over R2 plus 1 over R3. So you have to calculate this one, and after that, you can multiply these two, result of this, R equivalent to I equivalent, then compare that with the 12 volt. They must have very close result. Okay? So if our answers are correct, then no need to verify. If you are confident with this, that's enough, no? Then to save time. So do it consistently. So again, these problems actually can be solved. We call it as the solution. We are looking for the solutions to the circuits in series and in parallel. So to solve is you need formulas. Okay? So you have to provide everything for every point in the circuit. Provide the current, the voltage, and the resistance, and so with the source. And we call that as the solutions to the circuit, electric circuit, in series and in parallel. And of course, we need the formulas for parallel, series. We need also the formulas for parallel, and so on. Okay, so these are the problems in what? In series and parallel. What will happen if both connections are present within the circuit? And we call that as complex circuit. So we have this one problem for complex, and this is taken from the book of Young and Friedman, the University Physics, 14th edition. So we have here the EMF of 18 volts as a source, and the internal resistance is 0, meaning approximately 0. Then we have R1, we can call this as R1. We have 4 ohms, and we have 6 ohms and 3 ohms are connected in parallel. So 6 and 3 are parallel, and 4 is series to the source. So therefore, this is a kind of complex. If there is a presence of series and parallel, any circuits that contains two connections, series and parallel, is considered as complex circuits. The question is how to provide the solutions to the complex circuits. What are the process? Okay, the process very easy, very straightforward. All you need to do from complexity of the circuits, make it simple, which means that you have to convert the complexity to simplicity. And the question is how. Okay. Now, this problem, if you can convert, if you will solve this problem, you have to convert this into a simple. It can be a simple series or maybe a simple parallel. Look at the problem. 6 and 3 are parallel, which means that we can combine these two. Okay? We can combine these two and make it one. Remember, two resistor, the product of the two divided by the sum of the two, the answer is the equivalent resistance of these two resistors. And that equivalent resistance is series to 4, which means that since series sila, then we can add the two resistors, and the answer is R equivalent. But in this problem, you are asked to what? You are asked to calculate the equivalent resistance in the network, which means that you can solve that by combining this 6 and 3 in parallel. Then the result should be added by 4. Combining 6 and 3 is actually converting the circuit into a simple series. That's why the strategy of complex circuit is to compress it, make it simple. How to make it simple? Then look for the inner connections, inner circuits, then make it, combine it until such time that you will arrive the very simplest form. It can be a simple series or it can be a simple parallel. Then simple parallel can be combined into a simple circuit, one source and one load. At the one load, we call that as the equivalent resistance. Okay, so if we solve this one, this problem is actually very easy. Again, if you know, you have to combine this, one into one. So the combination of, I will call this as RA, the combination of 6 and 3, because 6 ohms and 3 ohms, these are connected in parallel. Okay, parallel. So therefore, parallel, if you combine the two, you can use the shortcut, the product of the two divided by the sum of the two. And this is 6 times 3 over 6 plus 3. And this is 18 over 9. And this is equal to 2 ohms. Okay? Is that correct? The product of the two, 6 plus 3, 18. Divided by, the product of the two, 6 plus 18. Divided by the sum of the two, 6 plus 3, 9. 18 plus 9 is, 18 divided 9 is 2. So we have 2 ohms. Which means that this circuit, the complex circuit now becomes simple. Okay? From complex, this is 4 ohms, and the 6 and 3 is combined to 1, and we have this, so which means that this is now 2 ohms. Okay? Take note, the EMF is 18 volts, and the internal resistance is 0, so we can skip that. And this is now series. Okay? So from complex, look at this one. This is complex. This is series. So what is the sum of the two? The sum of the two must be the answer to the problem, the equivalent resistance, because this is already simple. So this is 4 plus 2, the answer is 6 ohms. Okay? Even if how complicated the circuits, all you need to do is to combine the innermost circuit. So look for the inner. When you say inner, it should be the circuit, the connection that can easily compress into one. Then you have to construct the drawing again. Make it simple until combine, and then you can arrive the simplest form. So therefore, this is now the answer to the problem. What is the equivalent resistance? But take note, you are asked to calculate the current in each resistor, which means that we need to know what is the current that passes through this one. And I can call this as I1. Okay? I1. Okay? I1. Okay, that's it. Now, call this as I2. Of course, you can have a different name depending on your choice. And also this I3. Now, what is the current in I2? I1, I2, and I3. These are the questions, the follow-up questions. Okay, then the best way to do it is you can directly solve. You can solve. No? Take note that what's this? 4 is series to the source. What does it mean? The 4 ohms is series to the 12 volts EMF. In series, remember, current is constant. What does it mean? Whatever current in the source should be the current in what? In R1. Okay? So, in other words, the problem is, what is I1? This is the same as what? I equivalent. Which means that we need to calculate the I equivalent in order to solve for R1. This is one way to solve. Okay? Now the question is, what is I equivalent? Now remember, I equivalent is what? I equivalent is what? In Ohm's law, this is V equivalent, or this is the V equivalent. Our V equivalent is EMF or 18. Should be divided by R equivalent. Okay, again, in order to calculate I1, look at the circuit. The circuit, the 4 ohms is series to the source. Meaning, because series, whatever current in the source or the equivalent, I equivalent should be the same current in I1. So I1 should be equal to I equivalent. But what is I equivalent? I equivalent can be solved using Ohm's law, respectively. We need V equivalent over R equivalent. Our V equivalent is, remember, given as 18. This is 18. Divided by R equivalent is 6. So therefore, current is 3 amps. This is the answer for letter A, or I1. Okay. Did you see the process? If you know the principle in series and principle in parallel, even if how complex the circuit are, you can consistently solve that if you have this idea of series and parallel. So analyze the resistor properly. If it is parallel or series to one another, then if happens that given one of that given current, for example, then since series, then they must be the same. Okay, now the question is, what is I2 and what is I3? What is I2 and what is I3? Now look at this one. Look at this drawing, this one. In this drawing, remember that the current passes through this is I1, we call this as I1. And this is what? How much? This is 3 amps. Okay. Now remember that our combined resistor nga 2 ohms, which is the combined of 6 and 3, is series to the 4 ohms. Which means that the current that passes through this 2 ohms, which is the combined of 6 and 3, in parallel, of course, it will reduce. Okay? Because in parallel, the resistor is decreases its magnitude because we take the reciprocal of that. Which means that this is also This is also 3 amps. Why? Because they are connected in series. If we have 5 glasses of water that passes through 4 ohms, 5 glasses also should be passes through the 2 ohms. Or, since we have 3 amps of current, it should be 3 amps of current also passes through 2 ohms. But this 2 ohms, remember, is the sum. Okay? Is the sum of what? 6 and 3, which are connected in parallel. And always remember that in parallel connection, voltage are the same. Okay? Which means, whatever voltage in 6 ohms should be the same voltage in 3 ohms. And whatever voltage here should be the same voltage at this point. Now, what is the voltage? What is the voltage at 2 ohms? Of course, Ohm's law, voltage is what? R, which is 2 ohms, divided by current, multiplied by current, or current divided by resistance. The answer is 6 volts. Which means that since this is 12 volts, and the 6 volts is the voltage of 2 ohms, which is the combined voltage, 2 ohms, which is the combined resistance of 6 ohms and 3 ohms, then it follows that since this is 6 volts, the 6 ohms also has what? 6 volts also. Why? Because they are connected in parallel. Okay? And also with the 3 volts or 3 ohms should have 6 volts. Okay? Why? Because they are in parallel. Now, the question of what is I2 is now easily solved using Ohm's law. Why? Because we have already the resistance and we have voltage. The Ohm's law, okay, remember this. If there are 2 givens at that point, given information, then Ohm's law is very effective. Why? Because we can solve it. Because 2 of them are given, then the other one can be calculated. So in this case, R is given, B is given, and you are asked to calculate what's I2. So I2 is, of course, V2 over R2. But what is V2? What is V2? V2 is 6 volts, while R2 is 6 ohms. So therefore, the current that passes through I2 is 1 amp. This is the answer to the problem. Okay? Going back to this problem. A while ago, I said that since this is 3 amps, this must be 3 amps also. Whatever current that passes through 4 ohms should be the current that passes through 2 ohms, which is the combined of 6 and 3. Now, since we know already, take note of this, since we know already that V2 is 1 amp, then it follows that I3 is the difference between what? The 3 amps, okay, that passes to 2 ohms, which is 3 amps, should be subtracted by what? By I1. And I1, remember, is 1 amp. Okay? So the answer is, how much? This is 2 amps. This is the answer to the problem. Okay? Or, you can verify this, of course. How? Calculating I in Ohm's law. Remember, we have voltage 6 volts and we have 3 ohms. So this is what? This is 6 volts divided by 3 amps or 3 ohms in this case. This one. And the answer is what? The answer is 2 amps. And this is verified. Correct. So, these are the answers to the problem. Okay. Did you notice this is complicated, but this will become simple if you know on how to compress the circuit. So the idea of complex is to reduce the complexity. Then of course you have to use consistently the formula if it is connected in series, connected in parallel. And after that, analyze carefully the resulting compress, because you can find the answer on that compressing idea. So the hint is you have to construct the from complicated, then combine again until you arrive the simplest form. This is a technique of complex problem. Okay, so again, I have here this is coming from the book of Friedman. So meaning this is 18, and this is, what is this? This is 4 ohms, and this is 2 ohms, which is this one. Then we have now the compress. Okay, I think I will erase this one so that you can see the answer. Okay, we have here the solution. Look at the strategy. The strategy is what? From the complex, okay, this case, this is connected in parallel, so we can combine this. The result is 2. Okay, so this is actually the same drawing that we did a while ago. So meaning this is now from complex, we have this series, and we can combine this as one, and this is now simple circuit, one source, one load. And this 6 ohms is adding 4 ohms and 2 ohms. So therefore, that's it, no? And this is, remember, 12 volts, which means that the potential difference from A to B is also 12 volts. Okay. Now, therefore, the 6 ohms is the answer to the problem. What is the equivalent resistance? Because this is already in simple circuit. You can, from complex, naimos yung simple series, and we have this one simple circuit. One source, one load. Okay. Now, the current can be easily solved. Okay. I will. Okay. So, the current is what? 12, this is 18 volts divided by 6. So therefore the answer is 3 amps. So again, this is the same result as we did a while ago. The I equivalent is 3. So therefore, the current that passes through this is 3 amps. So then it follows that this is 18. Okay, so this is 3 amps. So therefore, I must be 3 amps. So whatever current that passes through at this point, the same, no? The same throughout, because this is no series, also this one. But this one, they have the same, different. So this must be 3 amps also. 3 amps, because this is 6 amps, 6 volts, 3 amps. So therefore this must be 3 amps also. And this is also 3 amps. So since we have these two, then voltage can be calculated. Okay? So we can calculate this as 12 volts. If we multiply 3 by 4, Ohm's law, and this is also Ohm's law, 6 volts, and the sum is 18. So, okay? So, verified. Verified as true. Now, this is 6 volts. So, meaning, this is 3 volts, and this is also 6 volts. 3 volts, okay? 6 volts, and this is 12 volts for the 4 amps, and this is 6 volts for this combination. And take note that this is parallel. Whatever voltage there is, the same here. So therefore, this must be 6 divided 3 equals 2, and 6 divided 6 equals 1. Of course, if you add this one, I1 and I2, the result is 3. This is another way to interpret the problem. Okay? So the strategy is compressing the circuit into a simple from complex. Okay, now, this is another, and this is the last, one other problem for complex problem. you are asked to solve for I1 and I2. Where is I1, I2? I1 is the current that passes through R1, and I2 is the current that passes through I3. These are only the required I1 and I2. Okay. So, how? Now, in this case, again, we need to compress this. The idea is, if you want to solve for I1, you should what? The idea is, if you want to calculate I1, remember in Ohm's law, is equal to what? B1, of course, divided by R1. Now, R1 is 8 ohms. Okay? But what is B1? Okay, what is B1? Now, look at this one. Remember, what is R1? R1 is parallel to the source. Okay? Why? Because there's no resistor here. There's no resistor within from the source towards this one. Okay. R1 is parallel to the source, but R3 is not parallel to the source, and also not parallel to R1. Why? Because we have here, you have this one. And also, R5 is not parallel to R3. Why? Because of this. And R3, and therefore, R5 should not be parallel to I1. And they are also not parallel to the source. Which means that R2, R3, and R5 are not parallel to what? To the source. Why? Because of this resistor, this one is not a parallel. And because of this resistor, R3 is not parallel to R1 and also with the source. So therefore, only R1 is parallel to the source. So therefore, in that case, we can easily solve for I1, no? Because this is just equal to 24. And the answer is 3. This is 3 ohms. This is the answer to the question, what is I1? Very easy to answer if you know the principle of the circuit. Again, this is very important that R3 is not parallel to that. Because if you do it, they are parallel, meaning you have to assume this as this is also 12 volts and this is 12 volts, then obviously it's wrong. Now, how will you calculate I2 here? Of course, you can use Ohm's law, and this should be B2 over R2. B2 over R2. Okay. But you don't know what is B2. You have R2 9 ohms, but you don't have B2. Now, what is B2? Now, remember, B2 is not series to the source, not parallel to the source, the resistor 2. So this is again a complex circuit. So, the strategy is, in order to solve for B2, we need to what? We need to solve for, look at this, one of the strategy. You need to solve for the R equivalent. And take note that if all resistors are given, any connections, as long as given sila, then you can always solve for the equivalent resistance. Okay? So, what's the advantage of that? If you know the resistance here, remember, the equivalent resistance is at that equivalent, then you can solve for I equivalent if you have this one. Why? Because we have equivalent voltage and we have the R equivalent, then R equivalent, then I equivalent can be easily using Ohm's law. But what is R equivalent? Of course, you have to combine everything. Okay, now, remember our task is to solve for I2. Now, what's the contribution of I equivalent and R equivalent to that? Okay? Now, if you know this one, look at this, very easy. If you know this current, okay. Now remember that current that passes through here will come into the circuit. This is I equivalent. And remember that we have already I identified na that I here is the I, that the current that passes through I1 is 3 amps. So therefore, if you know I equivalent, remember, at that point, I equivalent is equal to I1 plus I2. So this is already 3 amps. Okay? Unya, if you know this one, then you can solve for I2. Meaning I2 is equal to I equivalent minus I1. So the strategy is, again, to solve for I equivalent. And I equivalent can be solved using Ohm's law if you have R equivalent. So in short, we need to compress this circuit. We badly need to compress the circuit. Why? Because we want to calculate the I equivalent. And the I equivalent can be solved using Ohm's law at the source. B equivalent over what? R equivalent equals I equivalent. So let's do it. So all you need to do is to start with, we know already I1, remember that, is to combine. So look at the circuits. Which of the connections that can be easily combined? We call that as an inner circuit. So can we combine this one? R1 and R2? Are they parallel? No, they are not. R1 and R2 are not parallel. Why? Because of this circuit. Because of this. Without this one, without this, R2 and R1 are series, are parallel. Okay, meaning we cannot combine R2 and R1. Okay, look at this one. R3 and R4 are of course they are not series. Now, are they parallel? The answer is no, they are not. Why? Because of this. Because of R5 and R6. Which means that we cannot combine this one. Now, look at this one. What about R5 and R6? What is the relationship between the two? Yes, they are series. Okay? So, meaning, we can combine this. And also, R4 are series. So, meaning, R4, R5, and R6 can be compressed as one. So, therefore, that's one strategy. By the way, again, we have V1, whatever voltage here is 24. So, which means that I can be easily solved as 3 amps. Very easy. So, we can convert this by combining R4, R5, and R6. And this is now, how much? 11 plus 5 plus 3 equals 19. So, from this drawing to this drawing. Okay, now what else? What circuit can be combined? Yes, R3 and RA. RA is the combination of R4, 5, and 6. So they are parallel. Take note that we cannot combine with R1 because R1 is not parallel to R3. But R3 is parallel to RA. And R3 is not series to R2. Remember that. Which means that RA is not also series to R2. So of course, the next thing to do is to combine this parallel. So the product of the two divided by the sum of the two. And this is the result. If you multiply 2 by 19, then divide it, 10 plus 19, the result is 6.55. And we call this as RB. The RB is the sum of R3 and RA. So therefore, this is it. No? This is our third drawing. Then compress again. Because R2 and RB are what? Are series. Again, R1 and RB are not parallel. Be careful on that. They are not parallel. Why? Because of this. Without R2, then these two are parallel. But because of this, R1 is not parallel to RB. But RB is series to R2. Meaning, we can combine this. We can add 9 by 6.5. And the answer is this one. Meaning, it is 10.55. So, therefore, this is now a purely parallel. simple parallel, which means that we can combine this by taking the product of the two divided by the sum of the two. And the answer is 5.28. This is now a simple circuit. So from complex, look at the root. We have this complexity, then less complex, then more less, and then we have this parallel, and we have this simple circuit. The idea is bringing the complex into a simple circuit. And this is now our what? Our R equivalent. So therefore, since we have R equivalent, then we cannot solve for I. B equivalent over R equivalent. Then what else? This is 24 divide 5.28. Then the result is 4.55. So we have already I. So since we have I, we can subtract I equivalent 455 by 3, and the answer is I2. Okay? So I2, because I2 now is parallel, no, to this. Then therefore I can subtract. What? I equivalent 4.55 minus 3. The result is 1.55. And these are the answers to the problem. Okay? So I have here the for your activity, I will give you a problem. Then you have to find the solutions on this. And this is also the same as in your experiment. You will perform an experiment in this topic. So your activity, for practice, you have to solve this circuit. So the best thing to do is to tabulate. Again, we can say R1, R2, R3. Put it here. So R1, R2, R3. These are the points in the circuit: resistance, voltage, current, power. Remember power. We need to calculate. So the R equivalent of this, because they are series, then this 12 volts is the what? 12 is the I equivalent. So the lowest row R equivalent. So meaning this is R equivalent, V equivalent, I equivalent, and this is the total power. So this 12 is actually at this cell. So this is now how to. But you can interchange this, no? In this case, I call this as R1, R2, R3, and you can mix it, of course, in any order. But I think it's good if you will make it in ordered pattern. So R1, R2, R3. Then with that, supply everything in the cells. These are the solutions to the circuits. And this is theoretical. In our experiment, later on, you will be calculating the what you will measuring the elements here, then compare that with theoretical. So therefore, the first thing to do is to, of course, you can solve for the R equivalent by summing up, because they are series. Oh, be careful, if this is series, then of course you can add algebraically, but parallel, you have to use the reciprocals. Then since we have this though, if we have two quantities, then we can easily solve for I because of Ohm's law. So you can divide 12 by 60. Then after that, since they are series, all current must be the same. So the same. Okay. Then since we have this I, we have I and R, then we can solve for, that's the good of Ohm's law. No? Since we have already these two, then you can easily solve for voltage. Then you can verify this if these are correct by adding because in series, voltage will accumulate. Then add this one, then result is 12 volts. And there are many ways to calculate the power. You can take the product of voltage and I, or it might be I squared times R, or it can be B squared over R. Then you will arrive the same answer. Okay, so you can do it. 3 formulas can work on power. Then that's it. So you can use that, and you can add this 3. The result is 2.4. You can verify this by using the formula again, because these are inequivalent. Of course, you can use 12 times 0.2, or B squared over R, or I squared times R. They will arrive the same way. Or again, you can add this directly, and the answer is 2.4. the decimal will not matter. So these are the solutions theoretically to the circuits in series. And you can do it in parallel. So in parallel, again, you can arrange that way. But take note that the sum is not, because this is parallel connection. Okay? So therefore, you have that. Okay? This should be used in the formula. Then, of course, we have here, then, you can use Ohm's law. And this one, since parallel, voltage are constant, so you can use Ohm's law to solve that. Of course, very easy. Then power, the same. Then, again, as you said, no? So, you can easily solve that. Then, for complex, again, the process, again, you can use this one, combine. Then, combine it with that you can solve for the R equivalent. And after that, you can solve for I. And careful of this, because only 17, which is R1, is the same current with 4. So therefore, you can put it here, then use Ohm's law. Then, of course, this one, voltage, is 4 point. You can calculate that. Then, the same voltage here. Then, Ohm's law, then we have the power. Okay, that's it. No? So these are the different connections of 17, 22, 20, 23 resistors in series, parallel. So what do you think? Which connections are more consumable? Meaning, remember the power. These are the consumed power. So what connections that provides more power? Consume power. So if you compare the two, the total power consumed by series is 2.4. While in parallel, we have 21. So this is much greater compared to 2.4, of course. And this is 5 point in complex, because we connect to parallel, then one series. This is 5 point. But take note of the parallel, 21.9. So the parallel consumes a lot of power. But the advantage of parallel is, in the case of residential, we use always 220 volts, and it is compatible with the appliances. So you cannot use series, because if you connect series, you are adding voltages. So it might not. If you will connect the two electric fans in series, then connect it to the source, then your appliance will not work it well. Why? Because it does not meet the requirements of the voltage. So it might be slow, or it will not switch on. Okay? The disadvantage of series is, if one connection is lost, then everything will be lost. Why? Because current is constant. If one current is zero, the whole thing becomes zero. Now, in many appliances, the circuit is complex. Okay, so complex is are most likely to use in all the devices, because we want to look for what we control the current. So in order to control the current, then there must be connections of resistors in order to reduce the current. You want to know, you want only that amount of current, then you have to use the resistor, because resistor as a component used to regulate or to control the flow of currents. Okay, so that's all for today. These are the practice solving of problem, and this is the problem set. So you solve this and submit this next meeting. Okay, so these are the answers coming from the book of Young Freeman. Okay, so that's all for today. Thank you for listening.